Good morning, good afternoon, based on where you are in the world. You're checking us out today. This is the Unboxing AI webinar series, and today I will get it right the first time. We are at episode number 14, and we are joined by Larry Sitka. Thank you, Larry, for coming in today. This is as you know, this is a webinar series that we run here at CARPL. Essentially, we call our friends, collaborators, customers, partners, people we like to learn from, people we feel the world can learn from, and essentially ask a bunch of questions and have some fun for around 30 minutes. And for those of you who may not know, Carpel is your friendly neighborhood AI platform, AI marketplace. We're called many things, App Store for AI, but we are possibly the only FDA cleared AI marketplace out there today. 125 different commercial applications, build, test, deploy, monitor all of this stuff through a single integration, single user interface. That's what we are. And once again, today we're joined by Larry. Larry, for those of you who don't know, and or those of you who are like me who came to know him late in their DICOM journeys, if I may say so. So Larry currently is head of AI and innovation at PaxeraHealth. I think Paxera is possibly one of the most loved PACS companies out there. I think just the amount of good vibes that Mohammed and you, Larry, and then the broader Paxera team have is just amazing. Prior to that, Larry was at Canon, ran informatics and a bunch of cool things at Canon. And prior to that, he was creating this industry called VNA. So he founded Acuo, which is one of the seminal companies in the domain, all the way from VNA to routers, and I think you ran that for some 20 years, Larry. I think, uh,
That is
and
correct.
and yeah, so we're very fortunate to have you here, learn from you, and thank you once again, Larry, for being here.
Well, thank you very much for the opportunity. Greatly appreciated. Sometimes I get myself, like I said, in trouble. I come at this from a patient perspective, right? What would be my expectation as a patient? And knowing how data flows across these different elements, in our environments, it is really complex, but it doesn't have to be.
So, Larry, you know, we normally start these webinars by me asking the guest to describe what is it that they do as if they were telling a 5-year-old. So I would love for you to take a shot at that.
So our approach, or shall I say, the primary reason that I'm on my what I consider my last journey in my career, right, is I'm a very disruptive human being. From family, from engineering, from I'm a developer by trade, and there always is something better. So, in looking at all the different data flows that are occurring and are happening inside of these AI-based environments, the organizations really, and I'll say organizations, I mean vendors specifically, can't take applications that were built and created in the 80s and 90s and use them today. So we're on this next journey to reinvent PACS, shall I say, or leverage PACS in a way for this new user called AI. PACS has always been, and VNAs, they've always been focused on taking data in and persisting it. Now AI is all about perceiving data, right? It's just as the human is today. The biggest difference is humans today, they work from 6 to 6. They take
Mhm.
lunch breaks, right? They go home, they're on vacation. That never happens with AI. So the volume of data that we're going to see expectation on perceiving of this information is going to be 1,000 times the requirement of what we're currently seeing the humans access data. So what we've done is we've begun what I call a 3-year journey. When I came over to Paxera, I brought an individual that was my CTO over at Acuo, right, that I worked with very closely before Roz. He came from the Highland Act. He was still over at Highland slash Acuo. Um, we're bringing out an evolutionary platform that A, can sustain the performance requirements that are needed for AI, but B, also understand that the limitations of DICOM, the
Hmm.
limitations in terms of, so everything that I'll talk about today, the approach is from the data up,
Hmm.
right? I know the applications themselves coming down, you can't build an enterprise application from the user down. You have to build your foundation from the ground up, same way you build a house. And we're building an AI house that way.
So Larry, for those who are unfamiliar with the downsides of DICOM, right? The drawbacks of DICOM. What
Yeah,
would be, according to you, like the the two or three things that should have happened to DICOM as a standard, such that it would not require you to be building this from the ground up? Like, what could have happened? Because there's a lot of youngsters who typically join in for our
yep,
sessions, and then once this goes on YouTube, generally the audience has not seen what DICOM was, say, 30 years ago and what it is today. So if for that audience, like, what are two or three things that DICOM could have incorporated that it couldn't?
sure, sure. So unfortunately, I am one of those guilty party. I was actually involved in the DICOM 3.0 creation of the standard, right? The first one that I got was ACR NEMA 2.0, and then very specifically the print service, composite objects and the IOD definitions for print services. I was with 3M at the time. So they built the laser imager, so you can understand why. So
Ah,
it was
okay.
the biggest thing that I see right now that's missing from DICOM and still is, and it was causing a lot of, shall I say, inconsistencies in the environment is a conformance test,
Hmm.
right? When I was at Bell Labs and I wrote drivers, token ring, Ethernet, ATM, I actually, when I was done writing that driver, I would turn to IEEE and I could test it and I get a pass fail. Now, ONC has actually come out with a finite state machine for CCDA and CDA documents. That's perfect what they did. The underlying, though, DICOM is very, very fluffy, shall I say. I've
Hmm.
actually had the pleasure of written the DICOM stack 3 times, right, over my 35 years in this space. Inside of that, every time I read that standard, I came with something new. You know what I mean? There was something new in the words, and it let me
Hmm.
be flexible in the words because I didn't have a conformance test. So, if there was a way that DICOM could actually have conformance testing for modalities and then conformance testing for PACS to get rid of some of this private information that's being, and then standardized on the file formats.
Hmm.
Because I don't know if you've ever done a migration, but they are the hardest task to do. They can take anywhere from months to years to complete. And that's the exact proof point that, PAC systems and older VNAs can actually do exports of data, but not at the rates defined and required by AI. And then on the
Hmm.
PAC side, it's even worse. So what ends up happening is you have disjoint information. So in other words, data comes into the application and they write it to disk. It's a composite operation, right? A C
Yeah.
store, meaning you have patient, study, series, image, metadata, and then pixels for every single image. What happens is if they change the patient name, they only keep that update in their localized database and never change the file. So what that
This is
means
who
is
is
an
they? Who is they, Larry? Like when you say,
PACS.
okay, interesting.
Any ingest, well, even some VNAs do this, right? Any
Hmm.
ingest vendor that
Oh, and
takes
then
data
when they
in,
export, they kind of then do the write and
they merge it back on the wire. That's how they get it. But it means that the only way to really export this data to
is
migrate
to
it is you
both.
got to go back through the application stack. So
Hmm.
now you're dependent upon storage and the application and its database. So if they could get synchronization inside the files, right, as they sit on disk, we could actually leave files in place
Hmm.
and then just migrate the databases instead of migrate the actual storage. So that's one benefit from it that I could see. Now we're also moving towards a more secure file system, with S3 based implementations. You can buy appliances today that fully support S3 and byte offset reads inside of S3. So it's very efficient. And then that natively goes right into cloud-based architectures, whether it's Azure, whether it's AWS, or GCS services.
So that's interesting. So, what you're saying is from an AI perspective, if I was to, so I'm a doctor, right? So please excuse my uh, laymaness or lameness. So what you're saying is ideally, if there could be a system from an AI perspective that you have files that are already on some kind of storage, and ideally you don't need to take the files to the AI, but instead you're somehow able to uh, run the model on that very copy of the data and get
Exactly.
inference out of that, as opposed to having to create a copy of that data on some other disk somewhere, which takes time and effort and money, then run the AI and then get the output. Would that be like
That's
an
correct. What
okay?
happens
Okay.
today, what happens today is every vendor out there today looks at AI as this ancillary application, right? That
Hmm.
sits over here.
Hmm.
And what we need to do is bring AI inside the PACS as itself. So bring the algorithm to the data instead of sending data to the algorithm. So for example, the typical approach is, data will come to PACS. They have a DICOM router. The router routes a copy to this algorithm. And then it routes a copy to that algorithm
Yeah.
and that
Yeah.
algorithm. Now I have three
Yeah.
copies of the data. I
Yes.
have one in PACS and I have one out in the modality. So I got five
Yeah.
copies of a single study
Yeah.
versus if data comes into a service that we're calling it VNAI. It's a service that sits directly on top of the VNA.
Yeah.
Okay. And then now you move those algorithms to sit directly on top. So I have
Hmm.
one copy of the data, and now I can have five algorithms read that single copy of data directly.
But Larry, tell me one thing, like, would it not require, from a DevOps perspective, the algorithms to be containerized or essentially, uh, created in a certain different manner than like today, if there's 100 companies, like, we work with some 60 odd companies, and I'm sure there's like 60 different ways people do it today, right? Because
Yeah.
every CTO is applying their own brain to, optimize for their own deployment scenario. So, uh, how do you think, like, in as we head towards this journey, like, do you think all AI developers out there will start adhering to like a single stand or will need to adhere to a single way of, you know, containerizing or deploying their models?
I think you're spot on. I really believe that, I mean, containerization isn't new, right? It's
Yeah.
been around for 25 years. So, the first time I used containers was on a SunOps system. So it's not a new idea, it's not a new concept. Docker-based appliances are, right? So you have a container that runs on the Docker. The reason movement towards Docker is so that we can actually simplify the AI algorithms as a single microservice. So now you have these microservices that can run on that Docker appliance. Our vision is to move that AI inference engine, right, that enterprise Docker appliance into the modality group. So in
Hmm.
other words, the AI is happening in parallel to the delivery of the imaging information to the physician so that it's arriving so that when the doctor opens the study, the AI results are there instead of waiting for the AI results to come back. Because I'm hearing horror stories, right, about sending, an AI study to us, a study. One example, a mammography study was being sent to the cloud. It was taking anywhere from 20 minutes to 2 hours to get a result back, right, out of the cloud instance. 80 to 90% of that time was spent transmitting data.
Yeah. Yeah, I'm not
So
surprised.
so routing it to multiple locations. Now, if your VNA and PACS reside in cloud, perfect, right? And then you got to send it there anyways, but you shouldn't have to send it to another instance. You should be able to take that algorithm and run it natively on top of the data. So, and to take it a bit of a step further, the vision that we have and the reason we like AI inferencing and enterprise-based AI approaches is because we think AI will be used as second opinion.
Yep.
So, in other words, one of the things that really upsets the physician base is a false positive, right? When they have to go back into a study, unlock it because they got a ancillary AI result that came in, later. If they go in and they open it up and it's a false positive, they shut down, right? They almost refuse to use the application again. But what if you could take that AI result and go ask two or three other AI algorithms that were very specific? Do you have the same finding? And they
Yep.
all concur,
Yep.
right? If they concur, now, yeah, that's probably a pneumothorax. You know what I mean? That's what I'm talking about. That's exactly what happened in the financial industry.
Mm-hmm.
So when I first, and I can just this correlation of what I've seen historically. So when I first started out my career at Bell Labs, it was on the banking side, right? Network banking side and watching what was going on. And I personally then had this thing called a 401k, right? I had a stockbroker and they came up with this 401k thing. So I switched from my stockbroker over to this company called Fidelity Investments. When I did that, they printed my records, they transferred the data through the Fed, and they gave me a 12-inch floppy. Okay. That's what we're doing to patients today to transfer data for one. But what also happened is that advisor that I had over here, that stockbroker, no longer exists,
Yeah.
right? They're now portfolio managers. So they went
Yeah.
from an evolution of 10 to 12 stocks and monitoring to thousands of stocks and hundreds of EFTs. The amount of data that's generated over there in those data models is enormous. But they have an NLP that sits on top that puts it semantically together and then presents it through an LLM so a human can digest. That's what's going to happen here with AI. We're at its infancy. So we were talking before, and you were asking me about what would I see as a 10-year vision for healthcare. It's just that. It's just that where effectively we have assisting the doctor. Because right now what we're doing is we're disrupting the doctor.
Yeah.
You know, every AI vendor has their widget, right?
Yeah.
Every AI vendor has their own little, viewer. That
Yeah.
drives them absolutely nuts, right? Because it's popping up over here. I have this idea called texting and driving. You can't text and drive, right? When you're looking out your window,
Shouldn't text and
well,
drive.
and you can, but the result is a crash, right? So you're looking out your window, you see a text, you break the synaptic pathway, you
Yeah.
look down here, and then you have to come back. The reason they're
Yeah.
even going to heads up displays on cars for the mileage, the miles per hour that you're going, the speed limit, is because of this, right? So you don't
Yeah.
look down because every time you
Yeah.
do that, you break your thought process.
Yeah.
I was sitting with a neurologist about a month ago, and I walked him through this scenario of how we can make AI acceptable to the
Mm-hmm.
physician. He said we'd nailed it. He said we nailed it. Now we just got to get there to do it. In other words, every time a doctor looks at an image, it's opening up, right? They're measuring that time to first image. Oh, geez, there's a report over there. So I just got to look over there. Why can't you play the report in the headpiece?
Yeah.
Or if there's an AI finding, play it in the headpiece.
Yeah.
Don't put another widget over here with another set of text that I got to go read. That's the
Yeah.
texting and driving analogy, right?
Yeah.
Because it's very disruptive to the doctors. And we should have learned our lesson as vendors when it came to the EMR. What we did
But
to the
but
physicians
Larry,
that
sorry, I'm just gonna like double click on some of those thoughts. Uh, and I'm sorry, I'm being the text here. But
that's okay.
uh, but essentially, like, if let's say if I am a three people team uh wanting to build an AI solution for, I don't know, brain MR, right? I want to like auto report normal brain MRs or something like that, right? And I'm embarking on that journey today. What what should I do such that I am able to adhere to this future state architecture, which is actually not that far ahead because I'm sure you're already at year two of the 3-year journey. So what should I do? Like, are there some resources or are there some standards? Like, what can I do to containerize my model in a manner that is easily consumable by this future state?
So first step is think, take your physician hat off and put your developer hat on.
Yep.
So you have to think, what does a software developer do when they go create programs? The same context is true for going to create AI algorithms.
Hmm.
You need an IDE environment that allows you to curate, to build, to test, to verify, to rebase, to deploy, right?
Hmm.
All of these container-based AI algorithms.
Yep.
Okay, so that's the first step. In other words, what we're finding out there today is most of it is done just through file systems. It's done through, a lot of Excel spreadsheets. There is no verification, right? There's no re-verification of a lot of the AI algorithms out there. And even the ones that are FDA cleared, they're they're always version one,
Yeah.
right? They don't ever want to go back and do version two because version one was so expensive. But yet they're changing algorithms. What they're just trying to find out is when that algorithmic drift happens, has it drifted out of context so bad that it's now
Hmm.
inaccurate?
Hmm.
Or has the algorithm actually drifted very specific to the cohort that it was brought into? So taking one algorithm, defining it across the cohort, and making it 5 algorithms very specific to information that you could glean, out of genetics or out of some of the geography, right, of the
Yeah.
regions.
Yeah. No, cool. So we're going to jump to a couple of the questions that we've got, Larry. The first one is
Okay.
from Abhishek. He's from our team. So there are IHE standards for AI outputs, but they're still not followed by anyone. What do you think is the right way, or why do you think it's difficult to enforce them across AI developers?
It's again, this is part of the conformance, right? It's very easy, um, and this is just kind of a general paradigm inside of our space. It was always you take DICOM data in, and PACS systems would do whatever they want with the data. Nobody ever, right?
Scared. Yeah.
Nobody has an argument with yourself. You know what I mean? So it's when you have an indecision when you have two applications trying to communicate,
Yeah.
and now we're talking at the byte and bit level.
Hmm.
So I fully support those, like the air approach to the AI radiology approach, right? That IHE. I fully support what's going on there. Brian Bilecki has done an awesome job, bringing that forward from the ACR group. That's what's actually needed, and then conformance to it. We
Hmm.
also need then the providers to demand it.
Yes, that's what I was
Right?
coming to, Larry. Like, how do you enforce conformance when there's no regulation or legal,
Most of the
need behind it?
providers don't realize,
Yeah.
right? Most on the
Yeah.
provider side, most of the individuals have come up from, the bowels of HL7, the bowels of DICOM, and in their
Yeah.
environments, and they
Yeah.
don't run into a lot of these interoperability issues.
Yeah.
Again, I'll say in this space, it's if you've done one migration, you've done one migration. If you've done one VNA, you've done one VNA.
Yeah.
It's does the application have the tool set that's available for the users that are going to use and leverage it?
Yeah.
So the very first AI algorithm that is absolutely required is data normalization.
Correct. Of course.
So that's the very first thing that we need,
We need an
right?
open AI
And
for data normalization, harmonization, whatever we may call it.
yeah, yep.
No, that's
And
awesome.
then the second step is okay, find the body parts.
Yeah.
And then the third step is find the bounding box boundaries of those body parts and make all of that available to any PACS or any AI algorithm that wants to use it.
Yeah.
Otherwise, everybody has to go do the same thing over and
Yes.
over and over. And
Yeah.
the biggest problem there is with inaccurate data. you have human beings that can override, and they see, for example, study description. They see a Brian study and they say, oh, this is really a brain, right? Or a breast, right? Study one of the two. I mean, these are the things that they sound simple.
Yeah.
You know, Don Cram and Munif wrote an excellent article recently inside of Sim, talking about normalization of body part and anatomical region.
Yeah. Yeah.
There was a colleague of mine that ran VRAD, when they first started that group, and I said, this is really a bad problem. In the 6 months duration of studies, they saw 10,000 body parts.
I'm sure.
Now, how is an AI algorithm supposed to drive, right,
Yeah.
its findings? So every one of them
Yeah.
has to go in and look at pixels and
No,
say,
I think Larry, you've said it, you summed it beautifully at the start of your talk, right? Where you said that we have a new user or new consumer for the data, right? A human being can look at a brain and say it's a brain. They don't need to know that it's a brain, right? Now I'm just going to quickly switch to the second question we have. It says, "Hi Larry, like you mentioned, you would want AI to sit on top natively where PACS resides, and as of today, individual AI companies are not containerized. Okay. Do you see PaxeraHealth integrating an AI platform into their PACS offerings in the future to enhance the product capabilities and marketability, as they would solve the standardization of outputs from different AI problems, as well as can be installed on cloud beside PACS? Furthermore, it does solve the problem of false positives sitting in the packs as well. Oh, so I guess, the whole thesis, we've talked about this earlier, right? Like, whole thesis of having a AI platform that is not in packs, but separate from packs. Yeah, I would selfishly also love your thoughts on that.
it we actually do, right? We produce two AI inference engines, right, that are leveraged directly by PACS based solutions. So in other words, and we call it AI assisted,
Mhm.
right? Very simple things. What we're looking at is how can we optimize the reading side of what radiologists, and clinical staff do today. How can we make it faster? How can we take away some of the monotonous tasks that they have to do today? And we're growing that right from the base up. To do that, we had to normalize the data. We had to find the volumetrics. You know, our next approach now will be, now that we've found the body parts, right? Our next approach will be to, find lesions on those body parts so that when
Yep.
the study's opened and the finding is there, the measurement is, right on the screen. So again, we're not looking to override the physician, just do
Yep.
things that they would normally have to do by click, 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 click. So we have the separation point of, and I say two AI inference engines. One is for we build an AI curation platform called ARC, right? That
Yep.
development environment that allows you to build and publish those algorithms. Those are
Yep.
free, right? We run those free. We recognize though that there are a bunch of really good AI algorithms out there that can be used for fee. So we
Yep.
give kind of the best of the both worlds,
Yeah. Yeah.
right,
Yeah.
together, and then we bolt ARC onto those two environments so you can cross compare. This is one for fee, and if you created one, is it close enough,
Yep.
right? Or if they could import one that they're already using, is it close enough?
Yep.
So and I actually believe there's going to be this cross check between the two, right? There's going to be this AI second opinion.
No, I
Um,
think that's a beautiful way to kind of, as I mentioned, Larry, we try to stick to time, but I think that's a great way to end it. That there's going to be almost a balance, right, between so-called in-house slash free slash open source AI, and on the other hand, commercial AI. Maybe you'll have the commercial checking the in-house, right? You run like 100 studies through the in-house and like a sample of that through the commercial, or maybe something
that's
like
exactly
financial
what we
services.
prescribe, right?
Yeah.
Right. That's
So
exactly what we prescribe. I just was simply amazed at the number of AI algorithms already out there.
yeah,
I mean,
yeah,
just organizations, because these building an AI algorithm without an IDE environment takes a lot of person hours, right? There's a
yeah,
lot of grunt work a lot of searching, a lot of, just finding your cohort of
Yeah,
studies to run to train the algorithm is an enormous time frame, right? So,
of course.
those are the things that we're looking at simplifying.
No, that's awesome, Larry. We're gonna have to unfortunately close. But thank you so much for the time, for the insights. This is going to go onto YouTube, and we will share it far and wide. And any questions that come across, we will, forward them to you. But thank
Okay.
you so much, and I look forward to catching up soon again. And thank you to everyone for attending. And every Friday, 11 a.m. Eastern, this is going to be happening. So see you. Thank you so much, Larry.
Thank you
Thanks,
for the
man.
opportunity. Bye
No,
bye.